Again, welcome to statistics course. In this lecture, we're going to discuss about data classification in data analysis. Again, this is our Unit 2, lecture number 2. So first, we're going to talk about discrete data. Again, in statistics, we have two types of distribution, which is also based on the two types of random variable. We have the discrete distribution, and the random variable is normally based on counting. The same concept with discrete data. A discrete data is based on counting. Then we also have a continuous distribution, which is based on measurement, the random variable. So a discrete data, in the definition here, we say a data in which the observations are restricted to a set of values, such as 1, 2, 3, 4, that possess gaps, and this is called a discrete. But in short, a discrete data is based on, again, counting. We can say that we can be able to count 1, 2, 3, 4. We have 6 patients, or we have 20 people, but we cannot say we have 2.6 patients or 2.795 people. So discrete data is, again, based on the counting. It's based on counting. So a discrete data will be example 1, 2, 3, 4, 7 patients, etc. Then we go to the continuous data. Continuous data is based on measurement. So here we say the data that can take on any value within some interval is called continuous. So example will be the weight. The weight of a person can be 25.6 kilogram. And the pressure in a tie can be 20.0004. Again, continuous data is based on measurement. So we measure the pressure of a tie. We also, the weight of a person is not based on counting, but rather it's based on measurement. So those are the two major types of data. One data will be based on counting, which is discrete, and one data is based on measurement, which is continuous. Then we also have a level of measurements. So here we say the level of measurement is the quality of data. So the quality of data is referred to as its level of measurement. And we have 4 different types of level of measurement. Also, we can see that the level of measurement also still is based on the concept of discrete and continuous variables. So here we say when we are analyzing data, you must be exceedingly conscious of the data's level of measurement, because many stat analysis can only be applied to data that possess certain level of measurement. For example, we know in a research field, or if I'm doing hypothesis testing, I'm doing some analysis, everything will be based on the type of data that I have. For example, if I have a qualitative data, that is a data that can only be based on counting. For example, we have a data set about patients that have a specific disease. Now, one of our main variables will be the case, whether it's positive or negative, or true or false. Does the patient have the disease, or does it test positive or negative? So in this case, we cannot find the average or the mean of patients that test positive or negative, but we can find what we call the mode or counting. So that's one part, qualitative analysis. Then quantitative analysis will be based on values. So for example, I can find the average age of a patient that visited the hospital this year. So let's go through the level of measurement. So the first, we have the nominal data. So nominal data is the same concept as qualitative. There's also some textbooks use the term categorical. So nominal data is based on counting. So here we say data that represent whether a variable possesses some characteristics, and it's called nominal. For example, a patient tests positive, or a patient have a specific disease, yes or no, true or false. These are nominal data. So we can see that in nominal data, the only arithmetic operation we can perform on nominal data is counting. So it's distinctness, and that's something equal to some specific amount. We cannot find the average, or we cannot do any addition, subtraction, multiplication, no. So nominal data is only based on counting, either it's equal to a specific value or not equal. Next, we go to the ordinal data. The name already here suggests that this will be based on orderly. So for example, cigarette smoking, we can say, okay, if you're a heavy smoker, it's 1. A medium smoker, 2. Light smoker, 3. These are ordinal data. So 1, 2, 3, we cannot find average. We cannot even find the sum of it, because the 1 is not a value, it represents something. So the only arithmetic operation we can also perform here, either counting or less than, greater than relational operators. For example, maximum smoking, more cigarette, greater than lesser smoking, less cigarette smoking. So ordinal data, another example can be in the baseball league. We have New York Yankees first, Boston second, Toronto Blue Jay third. Now we cannot add the values 1, 2, 3 or find the average of it. They just represent a position. So it's in ordinal data. Next, we go to the interval data. With interval data, we can do some arithmetic operations, but most of them will be addition and subtraction. Now we say that if a data can be ordered and the arithmetic differences is meaningful, the data is interval. Example will be the temperature. And when a temperature is 0, it means something. So a temperature can be, again, interval data. Then we have the ratio. With ratio, we can perform all the arithmetic operations, either counting, relational operators, multiplication, division, addition, and subtraction. With the interval, we say we can only do addition and subtraction differences. But with ratio data, we can do almost everything. All the 4 major arithmetic operations. So here we say the ratio data is similar to interval data, except that it has a meaningful 0 value. So I was giving an example with interval. Temperature cannot be a ratio because a temperature 0 means something. With ratio, 0 means nothing. So for example, the balance on my bank account or checking account, if it's 0, it means I don't have no money. So the balance, bank account balance, is a ratio data. The temperature 0 means something, it's very cold. So it's interval data. So that's why the definition said ratio data is similar to interval data, except that it has a meaningful 0 value. Interval data have a meaningful 0 value. So let's see an example here. So for now, we have classified most of our data again. We talk about what is a discrete, what is a continuous, and also 4 levels of measurement: nominal, ordinal, interval, and ratio. Also, sometimes we may come across the term categorical. Categorical is kind of close to nominal. It's based on counting. Then quantitative is numerical data. And we may discuss this more later on. So here the question says, is the money a ratio variable? Say a friend has a $40 and you had a $20. Yes, it's a ratio because I can do a division. 40 divided by 20 is equal to 2. Money is a ratio variable because ratios, quotients are meaningful. With interval, quotient is not meaningful. So if someone does have $20 and you have someone does have $40 and you have $20, they do have twice as much money as you. So now we come to the qualitative data. We say qualitative data is measured on, as I said earlier, nominal or ordinal. Nominal, we can't do any arithmetic operation. Ordinal, also the same thing, only the relational operators we can do. So qualitative data is based on nominal and ordinal. We also have the term qualitative research. qualitative research, again, the concept also is that we are using a qualitative data. And also quantitative data is measured on interval or ratio scale. So with quantitative data, again, I can be able to do a numerical, I have a numerical value and I can do arithmetic operations and addition, subtraction, multiplication, and division. So that will be the conclusion of this short lecture. Again, this lecture we discuss about classifications of data in statistics. Again, the difference is only two. We have data that we can do arithmetic operation with. We have data that we cannot do arithmetic operation with. And this will be based on a research type also. We have qualitative research, quantitative research, and also mixed research. Mixed research means I'm using some qualitative data with a quantitative data. Now, we started with a discrete variable or discrete data. Discrete data is based on counting, and it normally is numbers 1, 2, 3, 4. Then we also discussed about continuous data. Continuous data is based on measurement, so it can be any value. 10.667, any decimal values are okay. With discrete, there's no decimal because we cannot say 25.7 patients. Either the patients are 25 or they are 26. Then we move on, we talk about the level of measurement and also the difference between quantitative and qualitative. So again, wish everybody the best and thank you for your time.